Good day. Welcome to chemistry class. Your tutor is Dr. Sadebi and today's topic is redox reaction, which is a continuation of my last posted video. Lesson objectives. At the end of this lesson, you should be able to identify oxidizing and reducing agents, balance redox equations. Oxidizing and reducing agents. An oxidizing agent is a part of the reactant that causes the oxidation of its counterpart while itself is reduced. This means that an oxidizing agent will cause oxidation of another element or compound while itself is going to undergo reduction. Reducing agent is a part of the reactant that causes the reduction of its counterpart while itself is oxidized. A reducing agent is a part of the reactant that will cause the reduction of its counterpart while itself is oxidized. In my last video, I talked about oxidation and reduction. If you've not watched the video, kindly subscribe to this channel and go and watch the video. Differences between oxidizing and reducing agents. An oxidizing agent is usually an electron acceptor, while a reducing agent is usually an electron donor. An oxidizing agent is usually an electron acceptor, that is, it will readily gain electrons, while a reducing agent is an electron donor, that is, it will readily lose electrons. Oxidizing agents are reduced in a redox reaction. Oxidizing agents usually undergo reduction in a redox reaction, while reducing agents are oxidized in a redox reaction. Reducing agents usually undergo oxidation in a redox reaction. Oxidizing agents have their oxidation number to decrease from left to right of the equation. Oxidizing agents have their oxidation number to decrease from left to right of the equation, while reducing agents have their oxidation number increased. So the oxidation number of reducing agent increases from left to right of the equation. That is, from the reactant to the product side. Identification of oxidizing agents. Now we want to learn how to identify an oxidizing and reducing agent. So the first step is for you to assign oxidation number to the element, to each element present on both the reactant and the product side, that is, both the left side of the reaction and the right side of the equation. You need to allocate oxidation number to each element present. I talked about that in the last video. Please, if you've not watched the video, do well to go watch it on this same channel. So, following the rules I stated in the last video, we've been able to assign oxidation number to these elements. Magnesium, I'm on the reactant side now. Magnesium is 0 because it is in its free state. There is no element attached to it, so its oxidation number is 0. And the same applies to oxygen. Its oxidation number is also 0. Now I'm on the product side, that is the right hand side of this equation. So we have magnesium in magnesium oxide. So the oxidation number of magnesium here, according to the rule of assigning oxidation number, magnesium is going to be +2, while that of oxygen is going to be -2. Now we want to find the reducing agent. Here I have that the reducing agent is magnesium. And how did I get that fact? Okay, so let's break it down and see what has happened. So magnesium has caused oxygen atom to lose one of its atom from the reactant to the product side. magnesium has caused oxygen atom in the left hand side of the equation to lose an oxygen atom on getting to the product side, meaning that magnesium has caused the reduction of oxygen, while magnesium itself has gained an oxygen atom from left to right of the equation. That is, magnesium has undergone oxidation. Therefore, magnesium is said to be the reducing agent. Looking at it in another way, we want to consider the oxidation number and use it to tell which is the reducing agent. So the oxidation number of magnesium on the reactant side is 0, while on getting to the product side it is +2. So that's an increase in oxidation number, and we are going to call that oxidation. While oxygen had its oxidation number to be 0 on the left hand side of the equation, and on getting to the right hand side it is now -2. That's a reduction in oxidation number. That is, oxygen has undergone reduction, showing that magnesium has caused oxygen to undergo reduction, while magnesium itself has undergone oxidation. Therefore, the fact has been verified that reducing agent in this equation is magnesium. Okay, now we want to find the oxidizing agent, and the oxidizing agent here is oxygen. So how did I know it is oxygen? It's so simple. Oxygen atom has been gained by magnesium from left to right. Magnesium has gained oxygen atom from the reactant to the product side, and therefore we now have magnesium oxide in the product side, showing that magnesium has gained an oxygen atom, and that is known as oxidation. And oxygen itself has its number of atoms to be decreased from 2 atoms to 1 atom, and that is reduction, showing that oxygen has caused the oxidation of magnesium, while oxygen itself is reduced. Therefore, oxygen is the oxidizing agent. And looking at it from another perspective, let's look at it from the oxidation number. So the oxidation number of magnesium on the reactant side is 0, and on getting to the product side is 2+. That is an oxidation reaction. That is, magnesium has been oxidized. It has experienced increase in its oxidation number, while oxygen has experienced a decrease in its oxidation number from 0 to -2, showing that oxygen has undergone reduction. Therefore, oxygen is said to be the oxidizing agent since it has caused the oxidation of magnesium while itself has been reduced. We want to learn how to balance redox equations. In balancing redox equation, the first step is to write out the oxidizing agent and the reducing agent as well as their products. And that will lead you to write out the half equation for oxidation and reduction. Then there is a need to balance the atoms first and thereafter the charges. And you have to balance the atom by adding appropriate numerical coefficients to the element or compound. Then there is a need to place the correct number of water molecule or hydrogen ion or hydroxide ion. So you use hydrogen ion when there is a deficiency of hydrogen in one of the sides of the equation. So you add hydrogen to the part that is deficient, and you add H2O water to the part that is deficient of oxygen. Where you have a deficiency in oxygen atom, you need to supplement it by adding H2O, that's the water molecule. then the H plus will be added, that is the hydrogen ion will be added in an acidic medium, while the hydroxide ion will be added in a basic medium in order to balance the number of hydrogen atoms. Then the next stage is to balance the charges. In balancing the charge, you need to add the correct number of electrons, and the electrons should be added in this sequence. On the right hand side of an oxidation half equation, you should add the electron. So the electron will be added on the right hand side of an oxidation reaction, while the electron will be added on the left hand side for a reduction half equation. So for the reduction half equation, the electrons will be added to the left hand side of the equation. The next step is to balance the electrons. So you need to balance the electrons by ensuring that the charges, they are equal both on the left hand side and on the right hand side. For instance, if you have SO3 2 minus, the charge there is 2 minus. Then if you have 2SO3 2 minus, the number of charge there is going to be 2, the coefficient, times 2 minus, which is the charge. That's going to give you -4. That's how to check out the electrons based on compounds, based on radicals, or based on ions. Okay, then you need to balance it out. You need to ensure that the number of electrons on the left hand side is equal to that on the right hand side. Then you need to combine the half equations. But before you combine the half equations, you need to eliminate the electrons. And electrons are usually eliminated just like we do elimination in mathematics. So we ensure they have the same coefficient before we add the half equations. Then, having combined the half equations, you now have your overall redox equation. So let's take a look at this example on balancing of redox equations. So we have sulfite ions and permanganate ions. They reacted to form sulfate ion and manganese ions. We have to balance the reaction using the half reaction method. So the first thing is to write out the equation that represents the reaction. And this is the equation representing the reaction. Sulfite ion SO3 2 minus is being added with permanganate ion MnO4 minus, and they gave sulfate ion SO4 2 minus and manganese ion Mn2 plus. Now we want to balance that equation. Let me take it backward. Okay, so having written out your equation, let's check out if the reaction is balanced before we even try to balance the equation itself. So looking at sulfur atom on the left hand side, we have 1 atom, and on the reactant side we have 1 atom. Oxygen is 7, 3 plus 4, that gives 7 on the reactant side, and on the product side it is 4, showing that it is not balanced. Then manganese is 1 atom, and manganese is 1 atom on the product, so manganese is balanced, but oxygen atom is not balanced. Okay, so let's also look at the charges. Don't forget that in redox reaction we are balancing two things, both the atoms and the charges. So let's look at the charge on the reactant side. We have 2 minus plus minus 1, 2 minus plus minus 1, and that is going to give -3. while on the product side we have 2 minus plus 2 plus. That's going to give a 0. That's minus 3 on the left hand side and 0 on the right hand side. That shows the equation is not balanced. So our job now is to balance the equation. So the first step is to allocate oxidation number to the element. Allocate oxidation number to the element. I saw that in my last video. So if you learnt it properly, you will find out that sulfur has the oxidation number of +4 in sulfite ion, while oxygen is -2 in the same ion. While permanganate ion Mn O4- has manganese oxidation number to be +7 and oxygen to be -2 in the same ion. Okay, now moving to the product side, sulfur has its oxidation number to be +6 while oxygen has its oxidation number to be -2 in sulfate ion. Then manganese is +2. Okay, now we've known the oxidation number. Now we have to find the reducing agent and the oxidizing agent. Okay, we have to identify the oxidizing and reducing agent. So looking at this equation, you could find your oxidizing agent and reducing agent in 2 ways. You could find them in terms of oxygen, probably oxygen loss or oxygen gain. Then you could use another method is to use the oxidation number. We use the oxidation number to find the oxidizing agent and reducing agent. Now I want to make use of the oxygen atoms. I want to use the oxygen atoms. Here we have SO3 2-, that's on the reactant side. But when getting to the product side, it is now SO4 2-. That shows it has gained an oxygen atom, and that is known as oxidation process. Okay, now SO3 2- is going to be our reducing agent. And why is it the reducing agent? It is a reducing agent because it has undergone oxidation, while it has caused the reduction of permanganate ion. The permanganate ion had 4 molecules of oxygen in the reactant side. When getting to the product side, it has lost all of its oxygen atom. That is reduction. So the sulfite ion on the reactant side has caused permanganate ion, which is its counterpart, to lose oxygen atom, that is to undergo reduction, while itself has been oxidized. Therefore, SO3 2- is going to be our reducing agent. Okay, now we've known our reducing agent. The next step is to find the oxidizing agent. Let's take a look at the other, that is the counterpart of sulfite ion in the reactant side. Its counterpart is permanganate ion. Permanganate ion, on getting to the product side, is now a manganese ion. That is, it has lost 4 atoms of oxygen, and that is said to be reduction. Okay, so let's find what it has caused for the sulfite ion. Looking at the sulfite ion, we are going to say that it has caused the sulfite ion to gain an oxygen atom to turn to a sulfate ion, showing that it has caused the oxidation of its counterpart, while itself has been reduced. Therefore, it is said to be the oxidizing agent. Alright. The next step is to add water molecule to the side with deficient oxygen. Looking at the 2 reactions, you will find out that the oxygen atoms is not balanced in any of it. And to balance the oxygen atom, we need to introduce water molecule, H2O. to the deficient side. Now I want to start with the oxidation reaction first. Okay, so we've added water molecule to the sulfite ion. So the next step is to add hydrogen ion to the side with deficient hydrogen. You will find out from step 3 that the product side of the reaction does not have hydrogen ion. It's deficient of hydrogen. Therefore, we need to add hydrogen ion to that side, to the other side of the equation. And we are adding hydrogen ion because we are saying it is taking place in an acidic medium. If it were to take place in an alkaline medium, then we need to add hydroxide ion. Okay, so let's proceed. We are assuming this is an acidic medium, therefore we are going to add the hydrogen ion, and we are going to be adding it to the right hand side of the equation. Okay, having done that, we need to balance the equation. And how do we balance the equation? We need to add the appropriate coefficient, the appropriate numerical coefficient to the deficient side of the reaction. So we have 4 atoms of oxygen, that is 3 plus 1, and that's 4, and on the product side it's now 4. Sulfur is 1 on the reactant side, on the product side is 1. Hydrogen is 2 on the reactant side, but on the product side it is just 1. That means we have to add hydrogen ions we have to add 2 to the hydrogen ion to balance the equation there. And the same thing goes for permanganate ion, the reduction process. So we need to add oxygen atom to the deficient side, which is the right hand side of the equation. Having added that, we need to add hydrogen ion to the other side where we added water molecule. So we now have this. And the next thing is to balance the equation. So in balancing the equation, we have equation 2. So let me take it from the previous step. We had 1 molecule of manganese, and we now have 1 molecule on the other side. Okay, we have 4 molecules of oxygen, and on the reactant side, but on getting to the product side is just 1. Hydrogen is 1 on the reactant side, and it is 2 on the product side, showing that oxygen and hydrogen ions are not balanced. Therefore, we need to add 4 atoms of H2O, 4 molecules. We need to add 4 as numerical coefficient, that is 4 molecules of water, and we now have 8 molecules of hydrogen ion. We have 8 molecules. By saying 4 times 2 to give 8, then we need to balance that equation. Okay, now we have our equation 1 and equation 2. The next step is to balance the charge. The next step is to balance the charge. And how do we balance the charge? I explained that a little bit earlier. In balancing the charge, you need to say the coefficient times the charge plus that of the other element, and then you continue. That gives you the left hand side, and the same goes with the right hand side. So let's take equation 1 for example. Here we have 1 sulfite ion, 1 molecule of sulfite ion. That will be 1 times 2 minus plus 0. 0 because water molecule has no charge, so it's just 0. That gives minus 2 on the reactant side of equation 1. Then on the product side, we have 1 times 2 minus, that is 1 of sulfate ion times 2 minus the charge, and that gave 2 minus plus 2 times plus 1. That's for hydrogen ion, and that gives 2 plus. So that's on the product side, we have 2 minus plus 2, and that's 0. On the reactant side, we have minus 2. That means we need to add 2 electrons. We are adding 2 electrons to the product side. And why are we adding it to the product side? We're adding it to the product side because that is actually the oxidation process. Don't forget I said earlier that the electrons will be added to the right hand side of the oxidation process. Okay, and here we have this. Now let's consider equation 2. We have minus 1 times 1, that is permanganate ion. 1 molecule of permanganate ion times minus 1, the charge, that gives a minus 1, plus 8 times plus 1, that gives 8. That's for the hydrogen ion, that gives plus 8. We have minus 1 plus 8 on the reactant side of equation 2, and that gives us a plus 7. While the manganese ion on the product side of equation 2 is going to give us 2 plus 0, which is that of the water molecule. Therefore, we have 2 plus on the product side of equation 2 as a charge, while we have plus 7 at the left hand side of the same equation, showing that we have 5 electrons there. That is 7 minus 2. That's 5 electrons that is deficient, and it has to be added to the left hand side of the equation. We add it to the left hand side because that is the reduction process. And the reduction process, we have 5 molecules of we have its electrons to be added to the left hand side of the equation. Therefore, this is what we have. We now have our equation 3 and equation 4. The next step is to cancel out the charge, and to do that we need to multiply equation 3 by 5 and equation 4 by 2. So why are we multiplying these both equations by 5 and 2? We are doing that to eliminate the electrons, because this step has to do with cancellation of the charge. Okay, and in doing that, it's just like what we have in mathematics, an elimination method while solving equations. If you want to use elimination method, you need to ensure that the coefficient or the variable that you want to cancel out have to be in the same, they have to have the same coefficient before you can cancel them out, and that is what is playing out here. So if we multiply equation 3 by 5, we now have 10 electrons. Then if we multiply equation 4 by 2, we now have 10 electrons too, showing that it can cancel out. And while you are multiplying, you need to multiply the entire equation. You need to multiply the entire equation, both the reactant and the product side. Okay, and that is why we now have 5 molecules of sulfite ion and 5 molecules of water on the reactant side of equation 3. Then we have 5 molecules of sulfate ion, 10 hydrogen ion, and 10 electrons. And that's going to give us the product side of equation 3. And all together, we now have our equation 5. And the same applies to equation 4. We need to multiply each of the terms, each of the reactant, and each of the products with 2. We need to multiply it by 2. And here we now have this. Okay. So the next stage, we now have our equation 5 and equation 6. The next stage is to add both equations together while you cancel out the electrons, because the electrons now have the same coefficient. It can be cancelled out. You should also note that similar reactant or product have to be merged together into one. For instance, we have 5H2O in equation 5 and we have 8H2O in equation 6. So we need to cancel out the part that is smaller, then we subtract it from the bigger one. That is, we need to remove 5H2O from the reactant side, and now we have 8H2O minus 5H2O. And that gives us 3H2O, which is going to be at the product side of our equation. Also, we have 10 hydrogen ion on the product side of equation 5, and we have 16 hydrogen ion on the reactant of equation 6. Therefore, we need to say 16 minus 10. That gives 6. And that will be at the side where we have excess of hydrogen ion. So we are going to have 6 hydrogen ions there. So in combining equation 5 and 6, we have 5SO32 plus 2MnO4 minus plus 6H2O. That's what we have on the reactant side. Then we now have on the product side 5SO4 2 minus plus 2Mn2 plus 3H2O. And this gives us our balanced equation. Now let's check it out to ensure it's balanced. We are considering sulfur atom now. We have 5 sulfur atoms on the reactant side and 5 on the product side. That's correct. For oxygen, we have 15. 5 times 3 is 15. 15 plus 2 times 4, that's 6, 8. 2 times 4 is 8. So we have 15 plus 8. That gives 23. Okay, now let's look at the product side. We have 5 times 4. That gives 20 plus 3 of H2O. That gives 3. So we have 20 plus 3. That's 23. Let's look at manganese. We have 2 molecules of manganese on the reactant side and 2 molecules of manganese at the product side. So that's balanced. Then let's look at hydrogen atom. We have 6 hydrogen atoms on the reactant side and 6 hydrogen atoms on the product side. That shows it's balanced. Let's look at the charge. So in balancing the charge, in checking the charge, we need to say 5 molecules of sulfide times the 2 minus, which is the charge. That gives minus 10. Then we have 2 times minus 1. That gives minus 2. That's altogether minus 12. Plus 6 times plus 1. That gives minus 12 plus 6. So that gives minus 6 on the reactant side. Then on the product side, we have 5 times 2 minus of sulfate ion. We have 10. We have minus 10 plus 2 times plus 2. That gives plus 4. Okay, so that gives minus 10 plus 4. That's minus 6. So on both sides of the reactant, both sides of the equation, both the left hand side and the right hand side, we now have minus 6 as the charge, which makes it to be balanced. Okay. So we have these exercises on this topic. They are WAEC past questions. Please ensure you go through them and attempt them. You might want to drop your answer in the comment section. Please feel free to do so. So these are the other questions on the topic. We have these small questions on the topic. You can solve them and drop your answer at the comment section below. Thank you very much for watching this video. Kindly like and share this video. Then please subscribe to my channel to see subsequent videos. For your home or online classes, you can contact me on my phone number, which has been displayed here. So in the next class, we'll be considering Faraday's law of electrolysis, how to solve problems on these laws. Solve problems on these laws. Thank you very much for watching. Thank you.